G'day viewers, in our previous two episodes we scientifically verified two of Bob Lazar's claims. Please watch episode 50 and 51 if you've not already done so. In fact, it would be prudent to watch all the videos on our Bob Lazar playlist. In this episode we'll scientifically verify a third claim. In this episode we'll prove Lazar correct by proving him wrong. How is that possible? Firstly, I highly recommend that you watch the Lazar documentary produced by Jeremy Corbell. In my opinion, aside from Lazar's government Bible documentary produced in the 1990s, the Corbell documentary is the next most important artefact in the Lazar story. It contains information critical to the third Lazar claim we're going to scientifically verify in this video. Earlier, I mentioned that we'll prove Lazar correct by proving him wrong. What did I mean? Well, to understand what I meant, you need to watch the Corbell documentary. In that documentary, Lazar discusses the manufacturing process of the element 115 fuel wedge used by the space aliens. He states that the element 115 fuel wedge begins its life as a bunch of discs piled one upon the other and fused together in order to form a cylinder. The cylinder is then machined into a cone. Once the cone is formed, it's sliced at mystifying angles in order to obtain the element 115 fuel wedge, which is then used to generate and amplify a gravity A wave signal emanating from the element 115 atom. Lazar states that nothing about the manufacturing process makes any sense to him, but apparently, if it's not done exactly that way, nothing works. Well, what Lazar is completely wrong about is that the element 115 fuel wedge manufacturing process doesn't make any sense. In other words, it all makes perfect sense and in fact is quite ingenious. However, we're going to show you in this video that although it's ingenious, you don't need more than a high school education to understand why everything is executed as per Lazar's description. I would estimate that the level of education required to explain the entire element 115 fuel wedge manufacturing process does not move beyond the 11th grade. It really is dead simple, but if and only if you have a critical piece of information. Without this piece of information, you can't possibly understand why the process needs to be the way it is. So what is this piece of information? What is so critical that we can't explain the element 115 fuel wedge manufacturing process without it? Well, the so-called missing link is the gravity A wave frequency we derived in the previous episode. Once we have this frequency, we have its wavelength. Once we have its wavelength, we have the entire element 115 fuel wedge manufacturing process. Not only do we have this, but we also have the means to determine the minimum batch manufacturing size required to produce zero waste. In other words, we have the knowledge to ensure that no element 115 material is ever wasted during the machining process, not a single shaving. Therefore, this implies that Lazar's element 115 fuel wedge manufacturing process is genuine, thereby scientifically validating his third claim. The next bit of footage you'll see is from the Corbell documentary. I have included this footage with subtitles and an audio overlay. The audio is an original composition by my late father. I have included an audio overlay so as to not ruffle any feathers. I respect the effort Corbell has expended and recommend to all viewers that you watch his documentary in full. Okay, let's move forward. Now is a good time to briefly review Lazar's three claims. Lazar's first claim is that the gravity A wave amplifiers burst released a gravity A wave signal towards the centre of mass of the Earth at a frequency of 7.46 Hz. That is, the gravity A wave signal is pulsed every 0.134 seconds. For the spacecraft to hover at the surface of the Earth, then this value of 7.46 Hz must be equal to the so-called gravity B wave emanating from the Earth, as stated by Bob Lazar. Lazar's second claim is that the element 115 atom generates a continuous gravity A wave signal which is subsequently amplified. The apparatus appeared to Lazar to be microwave-like technology. This means that the element 115 atom generates a continuous signal in the microwave frequency range. We estimate the frequency of this gravity A wave to be 11.44 gigahertz. So, to paint the complete picture of what's happening, the propulsion system generates a continuous gravity A wave signal at 11.44 gigahertz, amplifies it, then pulse releases that signal every 0.134 seconds, aimed at the centre of mass of the Earth. Lazar's third claim is that the antimatter power supply required a specific manufacturing process. This is what we're going to address going forward. Please take a moment to pause the video and study the information appearing on screen. Let's now do a quick review of what we accomplished in the previous episode, that is, episode 51. If you've seen our previous episode, this frame will be familiar to you. If you haven't seen this information before, please take the time to watch episodes 50 and 51. The critical piece of information relevant to this video is the fundamental wavelength. You'll see why momentarily, and once you do, you'll understand why it's important to review episodes 50 and 51. Comprehending how this fundamental wavelength was derived is critically essential information if you are truly interested in the physics behind the Lazar story. Let's now review the element 115 fuel wedge manufacturing process as described by Bob Lazar. This is an illustration developed by Ken Wright, and you can find it on his website. It describes the element 115 wedge manufacturing process in 4 simple steps. Step 1 involves stacking multiple discs, one upon the other. Step 2 involves fusing that stack of discs into a cylinder. Step 3 involves milling the cylinder into a cone, and Step 4 involves slicing a fuel wedge from the cone. If you're observant enough, you'll see that Ken Wright depicts 12 discs. Keep this in mind, we'll discuss it on the next slide. Okay, now that we've depicted the simplified process, let's do a deep dive into the complete process. This illustration explains everything we need to know about the element 115 fuel wedge manufacturing process in detail. We can see on the dimension sketch that 16 discs are utilised per cylinder. An obvious question to ask is, why have we determined 16 discs per cylinder and the Ken Wright illustration utilises only 12 discs? Well, I can't answer on behalf of Ken Wright. He may have just been guessing an even dozen. However, in our solution, it's due to the fundamental wavelength. The thickness of each disc is 1/4 fundamental wavelength. The reason for this is because the gravity A wave effect is, in a manner of speaking, switched off at 1/4 fundamental wavelength. This means that the gravity A wave effect is minimised perpendicular to the face of the disc, thus ensuring that when transporting the discs jumbled in a bag, their inherent gravity A wave effect cannot accumulate in any particular direction. If all the discs are randomly jumbled in a bag and the disc faces have all been switched off, so to speak, then the population of discs would be in their safest configuration for transportation purposes. You can also see from the dimension sketch that everything is expressed in terms of the fundamental wavelength, appearing as the letter R. You can see at the bottom of the sketch we have numbered pieces 2 to 8 and pieces 2' to 8'. This means that piece 2 mates to piece 2', piece 3 mates to piece 3', and so on. After slicing and the pieces have been mated by fusing, we have additional element 115 fuel wedges. Hence, each cylinder of element 115 produces 8 fuel wedges, including the primary fuel wedge described by Lazar and shown on the previous slide. Thus, the apparent mysterious slices described by Lazar in the Corbell documentary
are not mysterious at all. It all has a very logical explanation. When mated together, each new fuel wedge has a thickness of 1/4 fundamental wavelength. You should also note that once the cone has been sliced, the secondary fuel wedges all have rounded vertices. Let's now look at the table of information. To build this table, we have utilised the official scientific estimate for the mass density of element 115. We have applied the value of 13.5 grams per centimetre cubed. It should be noted that this value is slightly higher than the associated mass density required by the Lazar solution. Lazar stated that the mass of the primary fuel wedge was 223 grams, but we calculate a value of 238 grams. So, utilising the official scientific estimate for the mass density of element 115, we obtain a primary wedge mass result approximately 6.5% greater than Lazar's 223 gram solution. Given that the official scientific value is only an estimate based upon an unstable and fleeting element, no meaningful contradiction can be said to exist. Walking through the table, we see that only 1/3 of the cylinder is machined into a cone. The other 2/3 of material is milled away. If we assume that the shavings are collected, smelted and turned into new discs, then the minimum batch size of discs in order to ensure zero waste is 80 discs. From these 80 discs, 5 cones can be manufactured. This means that if each cone produces 8 fuel wedges, then from 5 cones we can expect to obtain a total of 40 fuel wedges. Please take the time to pause the video and study the contents of the table. It contains too much information to be discussed now. A quick video is a good video, so let's summarise what we've learned. In this video, we have proven Bob Lazar right by proving him wrong. We have proven Lazar right by deriving the fuel wedge manufacturing process in complete agreement with Lazar's description. We have proven Lazar wrong by showing how the entire fuel wedge manufacturing process makes complete sense and is entirely logical. In actuality, there is nothing mysterious about it once you have the critical piece of information, or in other words, when you have the gravity A wave frequency value we derived in the previous episode, that is, episode 51. For viewers wishing to understand the mathematics associated with the fuel wedge manufacturing process, please follow the links shown.